we are looking at constructing triangle similar to a given triangle as per given scale factor. First thing is, what is the scale factor and what is a similar triangle? To understand similar triangle, first we have to begin with taking up a triangle. So this is a triangle, say ABC, which is of length say 20, 14 and 12. If I have to draw a similar triangle, that is, I need to draw a triangle which is of same shape. It looks the same, but it need not be of same scale factor, need not be of same size. That's the difference. So triangle PQR is similar. It looks same as that of the triangle ABC, but it can be a smaller version, if not bigger version, or equal version. So in this case, it's a smaller version. Say this is 10, this is 7, and this is 6. It is a scaled down version. So basically, this is half of this, right? That's your new triangle. This is your old triangle. These two triangles are similar. So all the ratios, sorry, not all the ratios, all the angles are equal. A is equal to P, P is equal to Q, and C is equal to R. So these two triangles are similar. Now, what is the scale factor? To understand this, we will begin by looking into the variations and examples. Only then we understand it. If not, it's kind of tough to define it at one go. Say you have been given a ratio of 3:5, wherein the numerator is smaller than the denominator. The new triangle will always have a smaller value, and the old triangle will have a bigger value in the first variation, which I'm showing. That is a scaled down version. This is a scaled down version. This triangle is a scaled down version of the old triangle. So whenever you come across any ratio with a scale factor of small is to big, you need to have a scaled down version of the given triangle. Say I have a triangle which looks something like this. Right? And they want a scaled down version of this. So how you will construct this? You will construct a triangle something like this. By default, these two triangles will be, well, let's look at it. See, they are same to look at, is it not? Just that it is a smaller version of it. Right? So that's your new and that's your old. So 3:5. If this is of length 3 and this will be of length 5. So it's a scaled down version. The new triangle is a scaled down version of the old one. You got the difference? The other variation is, yes, you guys guessed it right. The new one is bigger than the old one. Say you have a triangle which is something like this, right? The new one would be a scaled up version. So the construction will look similar to this itself. So if you look at it carefully, I'll make you guys have a look at it. Right? Separate. Can you see that? Can you see this? The new triangle is bigger than the old one, and you can see to look at it looks similar. These two are similar. The new one is similar to that of old one, but if this is 5, this will be 3 because the ratio is 5:3. Right? So this will be a scaled up version of the old one. Understood? So there are two variations. Scaling is nothing but increasing, like you enlarge something and decrease something, right? Basically zooming in and zooming out. That's scale. So when you want to scale up, you zoom in. You make the side ratio increase by a particular factor. When you zoom out, you are decreasing by a particular factor. When you are using your camera, you get this 0.51, 1.52, right? All that is nothing but you're going near it. No, you're going near the, not exactly near per se, but yeah, you're zooming in by a factor of 2. So you will see a size which is twice what was the original size. You got the difference? Scale factor is nothing but the zooming factor. So this is how you construct. The basic idea is this, actually not this is how you construct. This is the basic idea of similar triangles, and when we know the scale factor, sometimes we have to increase it and sometimes we have to decrease it. So how do you determine when we have to increase or decrease? Looking at the ratio. So there's a trick. See, any ratio, it has a numerator and denominator. The numerator deals with the new triangle while the denominator deals with the old triangle. That is, if I see the numerator to be of a larger number than denominator, like 5:3, the new triangle will be bigger than the smaller one. If I see the numerator smaller than the denominator, the new triangle will be smaller than the old one. You got it? Here new triangle is bigger than the old one because the ratio, that is the numerator, is bigger. Here the numerator is smaller, so the new triangle is smaller. So basically this is what I wanted you guys to understand, because if you don't understand this and if you don't remember this, your entire construction will go wrong. That's why I have a separate video for the scale factor, right? So let's look at how to construct this in the next video. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification and calculation, DIY projects. We'll code with Python, we'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. There are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.